Hello, this is solving heat transfer coefficients using quadratic regression by BS Mechanical Engineering.
This study demonstrates the use of quadratic regression to analyze and predict the relationship between time and the heat transfer coefficient in a heat transfer experiment, which is an important field of study in mechanical engineering. In this content, data for the convective heat transfer coefficient is collected over time as the system approaches steady state. By fitting the data to a quadratic equation, heat transfer coefficient is equal to AT squared plus BT plus C. The trend was modeled, allowing for predictions at unmeasured time points. This method provides a simple and effective way to analyze experimental data, helping engineers understand heat transfer behavior and make reliable predictions. Regression techniques like this are widely used in solving real-world engineering problems such as material testing, system performance analysis, and optimization. Now, we proceed to the methodology. A. Set a tabulated results. Next is B. Express this time as a set of three simultaneous linear equations with three unknown variables a sub 0, a sub 1, and a sub 2. Lastly, use the general form of quadratic regression. Y is equal to a sub 0 plus a sub 1 x plus a sub 2 x squared plus e.
Hello, I'm Yansidena Pruebo, BSMA 3B. So, to the result and discussion, we have example using quadratic regression. A heat transfer experiment is conducted on a flat plate to measure the convective heat transfer coefficient H over time T as the system reaches steady state. The experiment is carried out at constant air velocity and temperature conditions. The following data is obtained for the heat transfer coefficient H measured in watts meter squared that Kelvin at the different time interval. So we have a time TAR where 0, 1, 2, 3, 4, 5, and heat transfer coefficient where H where watts meter squared that Kelvin have a 10, 15.8, 21.2, 24.5, 26.2, and 27. So here in the tabulated results, let x equals to t and y is equals to h. So we have I here. So the I is have a 1, 2, 3, 4, 5, 6 where this is our sequence. That's why our n is equal to 6. And here we have xi and yi. So the x here is our time TR. So we have a 0, 1, 2, 3, 4, 5 where the strain below the 5 have a equals to 15. So the heat transfer coefficient where the y sub I our h. So we have 10, 15.8, 21.2, 24.5, 26.2, and 27.0. And the strain here, so to find the strain here is the total amount of y sub I and so on. So the equals here is 124.7. And same goes by to the x sub I squared and x sub I cube and x sub I raised to 4 and x sub I y sub I and x sub I squared and y sub I, where after you put the results in the strain, our next is use the formula for finding the a sub 0 and a sub 1 and a sub 2. So we can use this formula where n a sub 0 plus strain x sub I a sub I plus strain x sub I squared a sub 2 is equals to strain y sub I. And next is strain x sub I and a sub 0 plus strain x sub I squared a sub 1 plus strain x sub I cube a sub 2 is equals to strain x sub I y sub I and so on theater. And after that, you can put the number where you can use the solution and put the 6 sub 6 a sub 0 plus 15 sub a sub 1 plus 55 a sub 2 is equals to 124.7 and so on. After you put all the solutions, so use the calculator where we're gonna compute the a sub 0, a sub 1 and a sub 2. So put a mod, then 5 equation, then find the 2 or the 3 unknown. We're gonna input the number. Where you can see the x is equals to 9.8785, so that is the a sub 0. And click again the equals where we can see the y is equals to 6.9678 or round up to 79, where the y is equals to a sub 1. And last is z. This is j is the a sub 2, where the answer is negative 0.7107. So after we find the a sub 0, a sub 1 and a sub 2, we have to proceed to general form of quadratic regression. So to find the quadratic regression, we have a h equals to a sub 0 plus a sub 1x plus a sub 2 x squared. So since finding here is x is the x is used to 6.5, so that is our finding. So after we use, so we're gonna input that in the 9.8786 plus 6.9679 minus 0.7107 6.5. And the final results will be your answer is h is equals to 25.1429 watts meter squared that Kelvin. So that is our final answer using the quadratic regression in heat transfer coefficient.
Good day, guys. I'm Prince Mark Nilias of BSMA 3D. For conclusion, quadratic regression is useful for studying heat transfer because it can model how things change over time in a curve. It helps turn complex data into an easy-to-use equation, making it possible to predict heat transfer values even when we don't have complete data. This makes it practical tool for understanding how systems reach steady state conditions, analyzing changing processes, and improving the design and operation of thermal systems. Mechanical engineering relies on the approach to solve real-world problems efficiently in experiments and industrial applications.